All images and videos are from projects developed using LÖVE. I shared an old video of a game I am currently working on a couple of weeks ago, and a commenter was surprised that LÖVE could manage a 3D game. So, this video is to address that, and I'll sprinkle in some updates for the games that I'm currently working on. The video in question was a quick test of my game Bologna. Bologna is a working title and may or may not be final. I don't know yet. But Bologna is a full 3D game with forward rendering and software ray traced shadows written in LÖVE 11.5, Mysterious Mysteries. However, LÖVE is capable of so much more. I have used LÖVE for at least a decade now after learning how fast and easy to use LuaJIT was. My first exposure to LuaJIT was from using Torch that would later become PyTorch for developing AI. After using LuaJIT, I found out about LÖVE and decided to use it to write an n-body simulation that tracks many orbiting bodies. I would play with canvas and have the particles paint and consume or annihilate each other. It was fun. Later, I would write a real-time physics simulation of the Lagrangian of a double pendulum, so I've been aware of how fast it can be for small, numerically demanding tasks. My other game in production is a fast, chaotic shmup with high demands for speed and accuracy. It uses LÖVE and a custom collision stack written in Lua, a broad-faced spatial hash table for enemies that's queried by player projectiles. When there is a hit, it falls to another stack of narrow-phase tests, first testing the projectile circle against the enemy's axis-aligned bounding box. If that returns a hit, it then projects the 3D geometry of the enemy vessel down into a screen space projected convex hull and tests against the circular projectile again using the separating axis theorem. It does all this and maintains pixel perfect accuracy with more than 350 objects on the screen while maintaining a steady 60 FPS. This is possible because LÖVE uses LuaJIT, a high performance just in time compiler and optimized interpreter for the Lua programming language, and it's impressive. You can often get similar speeds to compiled C. There is really only one caveat when it comes to making games, and that is it uses an older version of Lua, Lua 5.1. Lua 5.1 is a powerful functional language with closures, but has a limit of 60 up values. Up values are local variables from an outer enclosing function that an inner function or closure captures. It also has a limit of 200 variables per chunk. There are many ways to mitigate these limits that are used in Bologna, like table packing, where you pack your variables into a single table so it appears as a single variable instead, but this can cause variability in JIT. So from one machine to another, and even one run from another, you could see drastically different performances. This is probably the largest constraint of game logic complexity. You can work around these limits more efficiently by preferring dense integer arrays when the data is sequential, LuaJIT FFI structs for fixed layouts, and you can keep your hottest values as true locals or up values when possible. But this will be your largest barrier to writing modern-looking games in LÖVE. LÖVE11.x has OpenGL 3.3 and is therefore more than capable of writing smaller indie 3D games that can actually look quite impressive. It's capable of deferred rendering and physically based rendering, and even software ray tracing. Even Bologna employs optional real-time ray-traced shadows. What Love11.x does not have, however, is any sort of compute shaders. That locks you out of using your GPU for anything other than the very specific graphics pipeline they provide to you. It also doesn't have modern-day structures you want to see in a 3D game like a scene graph, frustum, or occlusion culling that are necessary for large, populated, detailed worlds. It provides limited UI and no editors or asset management tools. You need to build those yourself, and I often do. Stuff like a scene graph, frustum, or occlusion culling are all things you'll need to build yourself, and you will no doubt run into that Lua 5.1 variable and up value ceilings a lot. And again, introducing variability that would make a Six Sigma blush. So, those are the things you must consider. Now, I have forked, tweaked, and built my own version of Love 12. Love 12 already has compute shaders and Vulkan support. It didn't have access to hardware ray tracing, but it does in my version. Link is in the description.